Okay, parabol is inclined at an angle of 15 degrees, and parabol is projected from a point P above the plane with an elliptic speed of 20, an angle of 60 degrees above the horizontal. This means your actual crown angle is your 60 taken away your 15, which is 45 degrees. So you have a 45-degree crown angle parallel to the plane. So this is 20, sine 45, the cos 45. Try that into your calculator. 20 cos 45, you get 10 root 2. So they're both 10 root 2's. Perfect. 10 root 2. And another 10 root 2. Then next thing you need to know is when you go all the way up and you fall to the ground, time of flight was at Sy equals -1. Then you do your gravity triangle. Which is here. G. G cos 15. G sin 15. Now, sine 15, I reckon, has a lot of decimals. Oh, we can put it in third form. Do that at the very end. See sine 15? It's quite messy, isn't it? So in my opinion, you leave it in terms of sine 15, and then at the very end, change it. Otherwise, you're going to have a lot of extra work on your hands, okay? You don't want that. So I'm just going to leave everything in terms of sine 15, then it's not worth it. Now, Px equals 10 root 2 minus gt sin 15 gy equals 10 root 2 minus gt cos 15 sx is 10 root 2t minus a half squared sin 15. Sy is 10 root 2t minus a half gt squared cos 15. Pause and recheck your formula. Okay, time taken. So for the time of flight, Sy will equal -1. So all of this here equals -1. I'm going to change time of flight is going to be used given decimals, alright? So what I'm going to do is I'm going to convert a half g cos 15 into decimals. So 4.9 cos 15. Probably going to do 3 or 4 decimals here. Yeah, yeah. So I'm going for 4.733. That worked out nicely. So it's going to be 10 root 2 t minus 4.733 t squared equals -1. Move everything onto one side. We're going to get 4.733 t squared minus 10 root 2t minus 1 equals 0. My a value is going to be 4.733. My b value is going to be minus 10 root 2. My minus b value will be 10 root 2. And my c value will be -1. We're going to do the minus b formula in the calculator. Square root of minus b, which is going to be 10 root 2, plus square root of b squared, which is minus 10 root 2 squared. minus 4ac, so minus 4 times a all over 2a times 4.73. Time of flight of 3.057 seconds is grand by me. Perfect. Time of flight is 3.057. Alrighty. The speed of the particle at the point where it's traveling parallel to the inclined plane. Traveling parallel to the inclined plane. Now, this is an unusual one because what can we say? Parallel to the inclined plane. Now, it doesn't land parallel, does it? Right? But it's parallel to the inclined plane. So, why are you saying phi equals 0, is it? Yeah. Phi is 0 means when phi equals 0, it means it's not going up or down. Phi is in this direction here, and phi x is in this direction here. When phi equals 0, only it's traveling directly across, isn't it? Parallel to the plane. Parallel to the plane. Yeah, just do phi equals 0, and you should be able to figure out what you're doing there. So let's do phi equals 0. Grab this. Yeah, phi equals 0. What we can get out of this. So we can find the time quite quickly. 10 root 2 equals gt cos 15. Time taken is 10 root 2 over g cos 15. Time taken for that to occur should be 10 root 2. Yep. Over 9.8 cos 15. T value of 1.49 seconds. No bother. Now, do I have to do Pythagoras' theorem to find the magnitude this time? Why not? One of them's 0, isn't it? So it's only the phi x you need to worry about. Now, the phi x equation is here. Magic. Phi x is 10 root 2 minus g times t, which is 1.49, times sine 15, wherever that is. Has to be positive. So 10 root 2 minus 9.8, 1.49, sine 15 equals 10.36 meters per second. All right. Oddly enough,